Planning and scheduling are often used in the manufacturing sector to describe a common requirement, the development of future plan to satisfy the demand from customers. However, planning and scheduling tools typically have different objectives and very different functional footprints. This set of slides seeks to show the differences and why these might be important to you when selecting one appropriate for your needs. So what is APS? Yet another acronym for everyone to cope with, but traditionally and as defined by the APS, the American Production and Inventory Control Society, it is Advanced Planning and Scheduling. APS solutions typically have techniques that deal with the analysis and planning of manufacturing and logistics during short, intermediate, and long-term periods. They typically have inside logarithms that use advanced mathematical techniques or logic. It will use some form of optimization or simulation. It will consider multiple constraints, including materials, as part of the generation of the schedule or plan, and provide decision support to planners, including ATP, available to promise, and CTP, capable to promise, to decide when an order can be delivered, based on the current load and the availability of resources. APS solutions will offer ways to save and compare alternative schedule outcomes. In a survey carried out by the Aberdeen Group very recently, when companies were asked what were the most important features in an ERP system, APS came out top. 75% of companies said that APS was extremely important to them. However, only 19% of them had fully automated system within their ERP or used a third-party tool like Preactor. Most use spreadsheets to carry out the planning process. In order to understand the problem, we should look at the fundamental difference between planning and scheduling. Planning, typically available in an ERP system, is about working out how much we should make based on demand, either real or forecast into the future. Based on the demand, it works out what to make, how much to make, when to make it, and, in the case of multiple plants or multiple resources that can do the same thing, where to make it. Based on this, it will work out the load on resources, though it may do this with infinite capacity, and what materials are needed. Scheduling tools work out how best to make it. It works out the best way to execute the plan. It looks at the best sequence of work on each resource, works in real time so it will only load operations based on when all resources required are available, and generates a work-to list for each resource over the whole period of the schedule horizon. It will get feedback on actual times and help to manage the inevitable changes that may be required due to, for example, late arriving materials, breakdowns of machines, and changes in the priorities of orders. Planning systems typically work in certain silos, periods, or buckets of time. They will load operations into each bucket, which could be a day, a week, or a month at its extreme, but takes no account of the sequence of operations within each bucket. True scheduling systems are not limited in this way. It is bucketless. It will produce the exact time when each batch is due to start on each resource, and when it should end, taking into account the attributes of the previous batch, setup time, and run rates. So planning systems, with no access to what should be happening at any time during the schedule horizon, cannot give you a true mode that can predict what will happen at some point in the future. It cannot give real-time control of resources or individual orders. Planning systems typically sit above ERP, taking orders, stock and forecast demand, and working out what should be made in each bucket of time. We call this MPS, Master Production Schedule. Scheduling systems take information from ERP and carry out the detailed scheduling process, taking into account the sequencing required based on the rules and objectives you give it. We keep on talking about sequencing and why it can be important. This simple example shows why. We have 3 machines, A, B, and C. Each machine does one process step. They all work in an 8-hour day. All the components we make have the same 3 steps on the same 3 machines. In the example, we have 3 products, X, Y, and Z. The top table shows how long it takes for each operation step for each product. So product X will take 3 days for the first operation, 2 days for the second, and 1 day for the third. The run times for the other 2 products are shown too. The bottom table shows how the schedule would be if we added all the operations for X first, then Y, then Z. It takes 11 days to complete all 3 products. Now let us load it the opposite way around, Z first, then Y, and then X. There are fewer gaps, and all 3 products are completed in 8 days. That's 3 days less than before. On top of that, if, for example, we had sequence-dependent setup times, the mathematics becomes more complex. For example, it might take 1 hour to change from product X to Y, but 3 hours to change from Y to X. The influence of sequence-dependent setup times is shown here. We have 3 products again, blue, green, and red. The length of each colored bar represents the run time for the batch. This time we only have a single operation step. The black area between the colored bars is the setup time. The number on the bar is day required for delivery. Depending on how far we look ahead, we can go further and make further improvements, and the total time to complete all the batches is reduced. In effect, we have had a capacity gain. Let us show again why this has been obtained. In a planning system, operations are loaded into a bucket of time for each resource. As each batch is added, so it takes a portion of the capacity, and we have to take into account the setup time between each batch. Here we have added the orders up to the maximum capacity of the resource for this period, or bucket of time. Now let us look at the same load in a scheduling system. Here we have preserved the sequence that we load at each batch, and added the setup time between each. The preferred sequence is green, blue, then red, as this will minimize the setup time, and by doing this we have a capacity gain, or increased efficiency. Now it should be said that anyone can create such a schedule, given enough time to do it. Some planners use paper or boards to do it. Others use spreadsheets, Microsoft Project, or Microsoft Access, but these too can become unwieldy, slow, and difficult to maintain. As Mike Tyson, once the king of the boxing world, once said, everyone has a plan until they get hit. This is also true of manufacturing companies. Changes in materials available, changes in resources available, and changes in priorities are all punches that a planner must take on a regular basis, and APS tools are fast enough to fight back. Manufacturing companies are realizing more that to become more agile and deal quickly and intelligently with change, they must use an advanced planning and scheduling tool. It enables the planner to see the impact of change across the order book and try different ways of dealing with the problems that may arise out of the change. This is because true APS solutions accurately model time and the process, so can predict the real impact of change, and this allows planners to systematically make faster and smarter decisions. Thank you for watching our presentation. If you have any questions, please get in touch.